Hello everyone, welcome to watch the introduction video of our Thesis 2, an internet-based email target discovery platform. In the last semester, we have finished the whole basic workflow of the project, just as shown on the left part of the poster. However, there are still many places need to be improved, which is the work of our Thesis 2. One of the main parts is the improvement of searching. The original method we applied is Boolean searching, which has the following limitations. First, Boolean search will not support partial matching. Second, it will not provide any scoring or ranking results on the matched email address. Thirdly, it does not consider the word correlation, which stands for the quantified relationship among words. Last but not least, it cannot provide a way to compare two similar queries. Of course, we want to handle all these limitations. As you can see in the middle, this is the process flow of our design scoring algorithm. The inputs are the extracted content email pairs, which will be seen as a document set. And the input query from the users. First of all, we will filter out all the stop words such as up, that, for, off from the inputs. Both document sets and query since these words are considered useless or meaningless in searching or even may affect the performance of the scoring result. Then we do word correlation training on the document set. When we come to the word correlation training, we want to introduce hierarchical graph structure first. Hierarchical graph is a graph containing two layers. The first layer is the set layer. This layer is set because under our consideration, word correlation would have different values under different topics. So we want to train different sets independently, which are the pre-assigned topic sets such as sports and entertainment. The second layer is the word layer, which consists of several independent graphs formed by the words and their quantified correlation value. Each corresponds to a set in the set layer. We apply the idea of mutual information to quantify the value of word correlation. This is mutual information. However, we simplify the formula to have higher processing speed when facing large scale of data. This is our self-proposed formula. As you can see, NXY stands for the times that word X and Y appears together among the document set. NX and NY stands for the times that X and Y appears in the document set respectively. It is intuitive that if two words always appear together but have relatively frequency in the document set, they should have high information correlation. Then we go back to the workflow. After we have done the word correlation training, it is possible for us to handle the third limitation mentioned above, and then we can expand the input query to help users to cover the large range of information that they may be interested in. The final process is the advanced scoring formula based on TF-IDF. The calculation method is shown thus. We borrow the idea of TF-IDF scoring but have several improvements on it. In the formula, TF, T in DJ, stands for the term frequency, defined as the number of times term T appears in document. It can be seen that the more occurrence of a given term, it will lead to a higher score for particular document. IDF-T stands for the inverse document frequency. This value correlates to the inverse of the number of documents that a specific word term T appears. From the equation, it can be seen that the rarer the term, the higher the score the document will receive. CUHK is a new element that we add in the formula, which stands for the score factor based on how many of the query terms are found in the specified document. It is believed that more terms in the query are found in document, the higher score should be assigned to it. Query norm Q is another proposed element, which is the normalizing factor used to make scores between queries comparable. This factor will not affect the result of the ranking and scoring to a particular single query, but will result in comparable scoring result among several different queries. For example, the scoring response would be different to the following two queries. The first query is Nike football, and the second query is Nike football Macy. If only the two terms Nike and football can be matched in the document sets, the last element called length norm aims to normalizing the length of the documents. We consider that if the matching terms are the same, the shorter document should receive a relatively higher score. After calculating the scores, we can give a rank among the matched email addresses. According to our test, if the score is about 0.5, the result will be highly reliable. However, if the score is less than 0.16, it will be considered that the connection of the match is not that ideal. Last term, we have considered how to use Hadoop Nudge cluster to fetch websites. This year, we have updated the performance of the whole platform. In the web fetching area, last term, we can only fetch web pages on those websites which don't need login. This year, we have found a method to let the computer finish the login procedure automatically. To let the computer finish this job, we must know a new technology called automation browser. With automation browser, a web browser can be instructed to repeat the same, possibly long task automatically or at will. In daily, we can use automation browser to fill forms, extract data from the web page. Automation browser is often used for automating testing of web applications. And in our project, we use automation browser to provide authentication to a service. WebDriver is a tool for automating testing web applications, and in particular to verify that they work as expected. It aims to provide a friendly API that's easy to explore and understand, which will help make your test easier to read and maintain. And Selenium IDE has WebDriver to help us implement automation process. So if you want to log in to Facebook automatically, you just need to write a program with Selenium language in Eclipse with the environment of JUnit. Then we can automatically log in to Facebook anytime we want. Sometimes when we are doing our authentication, the website may ask you to type in the CAPTCHA. CAPTCHA is used to verify whether an action is done by a machine or not. To be honest, most CAPTCHA cannot be verified. For those simple CAPTCHA, for example, the random 4-digit number from 1000 to 9999, we can use a Java program to verify it. And this program is based on a technology called OCR. OCR is short for Optical Character Recognition. It contains 3 steps. First, we need to find each stand character and store them in the database. For each CAPTCHA, we need to split them into 4 numbers and compare each digit with the data in the database. Then we can get the result. Unfortunately, this method has a very low accuracy. So if you want to break a complex CAPTCHA, you need to use expensive commercial CAPTCHA breaker, which is usually paid by SEO, search engine optimization companies. The accuracy depends on the kind of CAPTCHA. For some CAPTCHA, the accuracy will be reached to 50%, but some can be even less than 1%. This is the whole introduction video of our Thesis 2. Thank you for watching.